All right, today we're talking about Chapter 9, Section 1, I believe. Statements, negations, and quantified statements. So today is going to be a lot of reading. Now again, it always bugged me so much as a student when I would have professors read off of the board. I don't know why, it just did. And it stuck with me to where, I want to make sure I never did that. With that said, today is going to be one of those days where I unfortunately am going to be doing a lot of reading off of this because today is going to be the day where we are just basically we're taking mathematics and putting it into sentences, and I'm pretty sure I think I've said this literally every single class period, but this class is so fun to me because it is what mathematics is. That this takes me back to actually going, taking third and fourth year math courses and actually doing what mathematics is. We're just not doing mindless computations. And again, y'all probably aren't there yet, um, but it just to me this is just a lot more applicable than the mindless computation, and you'll see why here in a moment. I don't suppose that would fit down there, do it? Okay, we'll just read it from here because it barely fits on the notes, and they'll be on the notes, but we're just reading it from here. Start from the tippy top. Again, there's no other way around it. It's just better to read this. Okay, so starting from the top, it says history is filled with bad predictions. Here are examples of statements that turned out to be notoriously false. Television won't be able to hold on to any market. People will soon get tired of staring at a plywood box every night. That is so. Actually, is that false? Because I don't know about you guys, but my TV is not plywood, right? So, but yeah, it's obviously false, right? Television definitely holds a market. The actual building of roads devoted to motor cars will not occur in the future. Everything that can be invented has been invented. Now that's an interesting thought. Everything that can be invented has been invented. It's interesting because um, I literally have this epiphany almost every single year, and then the next year something cooler and greater comes out. It just shows my brain power. So the abdomen, the chest, and the brain will forever be shut from the intrusion of the wise and humane surgeon. So guess what that's saying is that we will never be able to operate on all that. We don't like their sound, and guitar music is on the way out. Okay, so when the president does it, that means that it is not illegal. So these are all demonstrably false. Understanding that these statements are false enable us to negate each statement mentally and, with the assistance of historical perspective, obtain a true statement. We begin our study of logic by looking at statements and their negations. Now, the key word that we're looking at here is logic, right? So logic, we've I don't know if we've really touched on that word in particular in this class yet, but that's what we have been doing. We have been doing a lot of logical statements in those Venn diagrams and stuff. So statements using symbols to represent statements. Yeah. In everyday English, we use many different kinds of sentences. Some of these sentences are clearly true or false. Others are opinions, questions, and exclamations, such as help or fire. However, in logic, we are concerned solely with statements, and not all English sentences are statements. So the definition of a statement. A statement is a sentence that is either true or false, but not simultaneously both. With that said, um, I often tell people the one of the top 5 days of my life was when I completed English Comp 2 in college. And the thing is, the reason why it was such a great day for me is because I hated English. Okay, English was it wasn't something that I was particularly strong at, but I did it, and that's not gonna fit, is it? Mm, no, it's not gonna fit. Uh, but I did it, and little did I know that going into the heart of the math program, I had to use English a lot. and that's just the way it is. All right, I've since turned my changed my mind about English or language in particular. I actually think that English and language are very much needed, and in a way, that's what makes the world beautiful is language, the formation of language. So again, one of those things you didn't ask for, but there it is. So here we go. Here are two examples of statements. Of course, I don't think you really need an example of statement because I'm pretty sure you've said at least 100 statements today already, unless you just woke up, which that's fine. So London is the capital of England. William Shakespeare wrote the television series Modern Family. Okay, these are statements. All right. Now, are they necessarily true? We'll decide that here in a moment. So statement one is true and statement two is false. Shakespeare had nothing to do with Modern Family. As long as the sentence is either true or false, even if we do not know which it is, then that sentence is a statement. For example, the sentence, "The United States has the world's highest divorce rate." This is a statement. It's clearly either true or false. It's not necessary to know which it is. Uh, yeah, I guess. Some sentences, such as commands, questions, and opinions, are not statements because they are not either true or false. The following sentences are not statements. So notice how, do you see what I mean by this is just a lot of reading for this particular course, or this section anyways? It's like we're throwing back the English comp, huh? It's pretty awful. But we will see the finale here in a moment. So, think before you speak. This is an order or a command. Does just saying annoy you in everyday conversation? This would be a question. Titanic is the greatest movie of all time, and this is obviously fact. No, I'm just kidding. It's opinion. I don't even remember Titanic. In symbolic logic, we use lowercase letters such as P, Q, R, and S to represent statements. Here are two examples. So, what we're going to be doing now, uh, slowly, I think, I'm pretty sure we do get to it at the end of the section, but not in the first two examples. But we're going to be expressing these sentences as variables. Okay, so for many years you've expressed variables as unknowns. Okay, we're going to shake that up just a tad, and well, variables numbers as numbers. What am I trying to say here? For many years you've used variables p, q, r, s, x, y, so on and so forth to represent an unknown number. And now we're going to be changing things up. We're going to be using these letters to represent a sentence, a statement. Okay, because from here we're going to be using um, logic to figure out if a statement's true or false, or um, just using logic in the context of mathematics. And realistically, what this is the ground uh, the ground for is proving statements, and that is at the heart of mathematics. And that's why I'm so excited about this particular course, is because we're actually getting to the heart of mathematics. But anyways, again, I do this a lot. I'm sorry, but if you watch this on YouTube, put the speed up to two times. So P, Q, R, and S represent statements. Here are two examples. P, London is the capital of England. Q, William Shakespeare wrote the television series Modern Family. Okay, so we're going to let P be the first statement, Q be the second statement. Now, negating the statements. The sentence London is the capital of England is a true statement. The negation of the statement London is not the capital of England is false. The negation of a true statement is a false statement, and the negation of a false statement is a true statement, which makes sense, right? And so we're just taking the negation of it, right? Like the negative of it, essentially. Right? We're taking the negative of the statement. I think I already snipped that, actually. Yeah. Okay. So this says, from form the negation of each statement. So A, Shakespeare wrote the television series Modern Family. Okay, and I'm just going to go ahead and just snip the solution to this because I don't feel like writing it out. But we will say it before you actually get there. So form the negation of each statement. Shakespeare wrote the television series Modern Family. Okay, well, the negation of that would be Shakespeare did not write the television series of Modern Family. And of course you know that, and I'm pretty sure that many of you, if not all of you, are very talented arguers, and you nitpick sentences every now and then, and that would be one of them, right? Shakespeare did not write the television series. That's just a negation. Okay, and what's the negation of today is not Monday? Well, since today is not Monday, the negation of that would be today is Monday. Okay, so as you can tell, the negation of statements realistically 100% just evolve around. I'm sorry, revolve, not evolve. Revolve around the statement not. So if you can just remember that, which again shouldn't be abundantly difficult, Um, not is our operative word when it comes to the negation. Okay. Example 2, again, I'm just going to snip this whole thing. All right, so starting from the tippy top, we have, we're going to let P and Q represent the following statements. So P, again, is going to be Shakespeare wrote the television series Modern Family. Q is going to be today's, not Monday. So we're going to express each of the following statements symbolically. And did we actually touch on the symbolism here? Shoot, maybe I forgot to snip that. Yeah, I did. It's right here. Okay. In this text, the little tilde, I think it's called a tilde or tilde, is going to represent not. So what I mean by that is looking right here, this first statement, it says the negation of statement, the negation of statement P is expressed by writing, and then again, this is a tilde, I think, P, which means not P. We read that as not P. Okay. Another way to write it, and again, it's not in this textbook, but if you do pick up some alternate material to really understand this stuff, like you go to Khan Academy or something like that, you might see it written as this, not P written like that, right? And so those are two ways. So if we're going to express each of the following statements symbolically, right here, especially then Shakespeare did not write the television series Modern Family. Okay, well, if the statement P is Shakespeare wrote the television series Modern Family, and we're trying to write each of the following statements symbolically, right? Then what happens is this is actually the opposite. The sentence A is actually the opposite of P. So we would say tilde P or not P. Okay. And then Q, the statement Q is today is not Monday. Well, if I wrote that symbolically, this statement is today is Monday, which again is the negation of today is not Monday. So similarly, we would put not Q. Okay, so example P is, so we're going to let P represent the following statement. So P is a statement. The United States has the world's highest divorce rate. Express the symbolic statement, not P, in words. Okay, so again, without even looking at this, obviously I snipped it, whatever, it is what it is. All right, so if the statement P is the United States has the world's highest divorce rate, we need to express the symbolic statement, not P, in words. So how would I express that in words? Okay, well, if the United States has the world's highest divorce rate is P, well then all I have to do to uh, make this the negation, right? I need to write not P. It just simply say the United States does not have the world's highest divorce rate. And of course, that's what this sentence right here says. The United States does not have the world's highest divorce rate. Okay. And of course, as you know, there are many ways to express a sentence, express a statement. And so you can also express it as, it is not true that the United States has the world's highest divorce rate. So again, I don't think these are necessarily brain busters, right? But something that I will maybe just kind of touch on, if you take any of those, online IQ tests or something, these logical statements, they come up a lot because logic, at least in the Western world, has a lot to do with intellect. So we're taking those steps to really understand and formulate that mathematical mind with these kind of concepts. Also, for the record, I would not suggest taking those online IQ tests or IQ tests in general. There are many ways to express intellect, and those I don't know. Those don't do it for me. So more reading. I'm sorry. Just kind of follow along. To be quite honest with you, if you don't want to hear me speak and you're watching this YouTube video later, just fast forward and you don't have to hear me. But if you don't want to hear me, here we go. Quantified statements. In English, we frequently encounter statements containing the words all, some, and no, or none. These words are called quantifiers, right? We quantify something. We quantify it as all, we quantify it as some, or we can quantify it as none. A statement that contains one of these words is a quantified statement. Here are some examples. So, all poets are writers. Okay, makes sense. Some people are bigots. Okay, no common colds are fatal. Some students do not work hard. Not y'all, though. Using our knowledge of the English language, we can express each of these quantified statements in two equivalent ways. That is, in two ways that have exactly the same meaning. These equivalent statements are shown in Table 1. Okay, so if we look at our statements, okay, so our statements, we're breaking down our statements into equivalent statements and then just kind of using an actual example, okay? So the statement, all A are B, okay? So all of something is something, right? There are no A that are not B, okay? This is just another way to express it. There are no A that are not B, which, again, at this point in time, I'm really sorry. Unfortunately, you guys are my guinea pigs. I haven't really fleshed out this course yet. So I don't have an alternate way of explaining some things, and this is one of them. Uh, it's just one of those things you kind of have to wrap your mind around, and kind of get there on your own. Okay, so all poets are writers. There are not poets that are not writers. Okay, so that coincides up here, right? All A are B, and then if we can also, and I'm pretty sure it's called a contrapositive, but I'm pretty sure we'll talk about that in this section, but that's kind of like what that is. Some A are B. Okay, so there exists at least one A that is a B. So some people are bigots, and at least one person is a bigot. Okay. No A are B. So another way to express it is all A are not B. So no common colds are fatal, or all common colds are not fatal. And then some A are not B, not all A are B. Some students do not work hard, not all students work hard. And again, these are just logical equivalent statements that at the end of the day you just kind of have to put your mind around. I'm pretty sure, and that just adds on to stuff. We'll put sounds like somebody's attending class in a traffic jam, which good for you, to be quite honest with you. Maybe we should go back to that because I think this piggybacks. So let's actually go back to this uh, table to the right here. So forming the negation of a quantified statement can be a bit tricky. Suppose we want to negate the statement, all writers are poets. Because the statement is false, its negation must be true. The negation is not all writers are poets. This means the same thing as some writers are not poets. Notice that the negation is a true statement. Okay, so I guess not necessarily big deal there, but notice how. So we're saying that all writers are indeed poets, but at the same time we have poets that are not writers. Wait, I'm sorry. We have I said that completely backwards. All poets are writers, but at the same time, not all writers are poets. That's what I'm trying to say. All right, and of course we do indeed see we do indeed know that's a true statement because you've read, I'm pretty sure you've read tons of books, but they're not all in poetry, right? The negation would be some writers are not poets, which again makes sense. So in general, the negation of all A are B is some A are not B. Likewise, the negation of some A are not B is all A are B. So again, it's just the phrases flip backwards, but it is very important. So let's actually, I wonder if I can, I don't want to underline it. Maybe we can highlight it because this is a very big deal. Okay, the negation of all A or B is some A are not B. Big deal. Write that down. And I think I already snipped that. Yeah, So next up, now let's investigate how to negate a statement with the word some. So consider the statement, some canaries weigh 50 pounds. Holy cow. Because some means there exists at least one, the negation is, it is not true that there is at least one canary that weighs 50 pounds. Because it is not true that there is even one such critter, we can express the negation as no canary weighs 50 pounds. I mean, that's not true, right? That's not a true statement. I don't know. I don't know. I don't necessarily know my birds, but 50 pounds is quite a lot. Um, and of course, we'll highlight this as well because it's also important. In general, the negation of some A or B is no A or B. Okay. So same thing as the previous, the first table we did. Negations of quantified statements. So if we say that all A are B, then we know that the negation is some A are not B, which makes sense, right? And of course, an example would be all people take exams honestly. The negation would be some people do not take the exams honestly. Okay, and that's just a negation of it. And then some A are B, no A are B. So some roads are open. The negation is no roads are open. So here's a great question I snipped. Let's see. Is there a way to help me remember the negation of quantified statements? This diagram should help. The statements diagonally opposite each other are negations. So all A or B, the negation is some A are not B. And some A or B, the negation is no A or not are B. This is actually a lot better than what I just what I've been highlighting. So yeah, this is much better. So in fact, the thing I said earlier about you want to write that down, write this down, or snip this or whatever. This will carry you very far into our logical statements that we're going to be doing probably the rest of this chapter. All right, so here are some examples of negation. So all humans are mortal. Some humans are not mortal. All right, so notice how we go from all to some, right? Some students do not come to class prepared, and then all students come to class prepared. Some psychotherapists are in therapy. No psychotherapists are in therapy. No well-behaved dogs shred couches, and some well-behaved dogs shred couches. So again, notice the words, and I mean honestly, it's logic. You have to wrap your mind around the logic of it. And of course, I mean I'll do my best to try and help you out, but the all and some and no, just kind of remember this table. I think this table will be really good for you. And then finally, here at the end, so example 4, we have the mechanic told me that all pistons rings were replaced. Okay, so remember, we have all. Okay, I later learned that the mechanic never tells the truth. What can I conclude? So if the mechanic never tells the truth, okay, there's going to be a couple of statements we can kind of derive. So if he told me all piston rings were replaced, which by the way, this really puts mechanics in a bad light. But anyways, nobody trusts mechanics, and that's unfortunate. All piston rings were replaced. So if he never tells the truth, what would we say? And again, we say that we look at all. Okay, we come over here. We say all A are B. So therefore, we can conclude that some A are not B. And in that problem, A were piston rings and B was replaced. Right? All piston rings are replaced. So if our mechanic here is notorious for not telling the truth, then we can logically conclude that some piston rings are not replaced. And of course, that's what we see here. Some piston rings were not replaced. Okay. And then we can also, again, equivalently conclude that because some means at least one, I can also correctly conclude that at least one piston ring was not replaced. So that does conclude today's lecture.